This is V here, and I'm here with your second round of your lesson on stoichiometry. And today, yesterday we went from moles to moles. Today we're going to take it one step further. So we're going to go from moles to grams. Okay. If you need help after this lecture, you can go into your chemistry book, and it's pages 360 and 361, totaled mass to mass calculations. And it does take it a little bit farther. It starts it with the mass instead of the moles. But you really are only going to be tested on starting with moles, going to moles of another molecule, and then to the mass of that wanted molecule. Okay, some definitions to review. Number one, a mole equals 6.02 times 10 to the 23rd, which equals X grams, which is our molar mass. Okay. A mole ratio is a conversion factor created from a balanced reaction. You convert moles of one molecule to moles of another in the reaction. Molar mass, it can be written two different ways. It is a ratio, is X grams per 1 mole or 1 mole per X grams. Now the X grams comes from you calculating the molar mass of the molecule from the periodic table. Okay, so why mole to mass conversions? Why do we do it? Well, the most important thing is we cannot measure a mole easily. So I cannot go into a lab, such as I told you when I make solutions for some of your reactions you guys saw when we did types of reactions. One of the things I could not do was I could not go in, and I don't have a mole measuring device for me to measure moles. So remember, moles is 6.02 times 10 to the 23rd thing. So I would have to count that many atoms, and I don't really have that kind of time. So we use this because now we're going to convert back to grams, which is a much easier thing for me to measure in the lab. So we use it so we can go from moles back to the mass. Okay, and we can measure mass of reactant or mass of products that we can make. We can actually physically measure that. Okay, so let's look at number one. So we're going to start with our balanced equation here, which is 1 mole of nitrogen plus 3 moles of hydrogen. We used that yesterday, yields 2 moles of ammonia. So if you have 2 moles of nitrogen, how many grams of ammonia are produced? Oh, and I almost forgot. I forgot to check if it was balanced. So I have 2 nitrogens, 2 nitrogens, 6 hydrogens, 6 hydrogens. We're good. So if you have 2 moles of nitrogen, how many grams of ammonia are produced? So our first step is we're going to start with our given, which is here. Okay, 2 moles of nitrogen. And what I am hoping is, as you guys were having to do the mole ratios yesterday, that we don't have to write the 2 possible mole ratios, that we can just skip to making sure that we're writing it correctly. So we're going to start with our given, 2 moles of nitrogen. These are the units that I have. So I'm going to put in my conversion, when I multiply by it, moles of nitrogen on the bottom, because that is what I have. And I'm going to go up to my balanced equation to get my numbers. So moles of nitrogen. So I have 1 mole of nitrogen. It tells me I'm going from nitrogen to ammonia. So I'm going to need moles of ammonia on top, which I get 2 moles of ammonia there. Then what's going to happen, because I am not to grams yet, what am I going to have to do? I'm now going to have to use my molar mass that we learned a couple weeks ago. Well, since I now have canceled my moles of nitrogen, I am now in moles of ammonia. So now these are now the units I have. So I'm going to put them on the bottom. So moles of ammonia. And remember, the other unit in our molar mass is grams, okay? And if you do not remember how to calculate the molar mass, please go back to those videos to refresh yourself. But I calculated it here. And there are 17.04 grams of ammonia in 1 mole of ammonia. And this is calculated from the periodic table. But as you can see now, because of the way I set it up, moles of nitrogen has canceled moles of nitrogen. Moles of ammonia, canceled moles of ammonia. Remember, in chemistry, we do not cancel the numbers. We only cancel the units. And the only units I'm going to have left are grams of ammonia. And that is what I'm looking for in my question, grams of ammonia. So then again, just like the PEMDAS rules, it does not matter how I do it. So it'll be 2 divided by 1. Remember, you divide by anything on the bottom, times 2. Okay, or 2 times 2 divided by 1. Then we're going to times by 1704 and divide by 1. And I will end up with 16.6 grams of ammonia. So what does that mean? It means if I have 2 moles of nitrogen, and I have more than enough hydrogen, I don't even have to measure it, have a ton of them, then what I'm going to make is actually, I'm going to make 16.16 grams of ammonia. And I can actually calculate that and see that. I can measure that. But that tells me how much product I'm going to make. Okay, let's look at example 2. So we're going to use the same balanced equation, but we're going to use it in a different way. So we have our balanced equation, 1 mole of nitrogen plus 3 moles of hydrogen yields 2 moles of ammonia. We need to make, it says here, we need to make 2 moles of ammonia. So you'll underline this. How many grams of hydrogen do we need? So now we know our products, and now we need to figure out, well, how much hydrogen do I need to make those 2 moles of ammonia? So the first thing you're going to do is you start with your given. And it's going to be 2 moles of ammonia, which are right here, 2 moles of ammonia. Notice I'm writing the molecular formula every single time. This is now my given. So I'm going to write my given or my have units on the bottom, moles of ammonia. And from here, it tells me on my question, I'm going from moles of ammonia to moles of hydrogen. So moles of hydrogen will be on top. And from the equation, I know 2 moles of ammonia, okay, is in ratio with 3 moles of hydrogen. So now I have my first conversion. That's my moles to moles, okay? Now I need to go from moles to grams. Well, the only way I can go to grams is through the molar mass, okay? And I'm going to end up with grams of hydrogen. How many grams? So that's why I've calculated the molar mass of hydrogen. So now, when I've set this up, the moles of ammonia have now canceled, and I'm in moles of hydrogen. So now I'm going to put moles of hydrogen on the bottom because that is not what I want to be in. I want to be in grams of hydrogen. And I will put grams of hydrogen on the top from the molar mass, which causes my moles of hydrogen to cancel. Okay, and 2.02 grams of hydrogen, that is calculated from the periodic table. And then I just read it across. So remember, anything on the bottom you will divide by, anything on the top you multiply by. Does not matter how you read it. So 2 times 3 divided by 2, or 2 divided by 2 times 3, okay? And then we're going to divide by 1 and multiply by 2.02. And you could multiply by 2.02 and divide by 1, and you will get 6.06 grams of hydrogen. So what does that mean? That means if I have 2 moles of ammonia, okay, if that's what I want to make, then I need to definitely start with at least 6.06 grams of hydrogen, not moles, grams. So I can definitely measure that, okay? All right, so let's go ahead and let's look at your Poggle today, okay? So let me get that in, okay? Okay, there it is. So we've got our Poggle for today, and we are going to do today, we're going to do questions 9 through 26, and I'm going to go through 9, 10, 11, and 12 with you. Okay, so let's look a little bit at our example here. And of course, it's just as we did there on our examples here, except it says how many grams. Remember, I always underline what I can. Grams of hydrogen, moles are needed to produce 34.8 moles of ammonia. Okay. Remember, you can write out your mole ratios, hydrogen to ammonia, if you're still having trouble, but I'm not going to do that in this one right now, okay? So it also told me, one of the things I do notice all the time is if I have grams in my in my question, I already know right away I have to calculate the molar mass. And since I'm going to go from grams of hydrogen here, how many grams of hydrogen? I know I need the molar mass of hydrogen. So up here it's already calculated for me, and here they ran it to 1.0, so 2 times 1 is 2 grams per mole is the molar mass of hydrogen, okay? So my first step is to do my given, 34.8 moles of ammonia. I have moles of ammonia, and there's 2 moles of ammonia, okay? I'm going to hydrogen here, to 3 moles of hydrogen, okay? And then my moles of ammonia can cancel, okay? Because I'm looking for grams of hydrogen. So now I need moles of hydrogen here to cancel. And I'm going to put up here grams of hydrogen, okay? Now I know from my molar mass, in 1 mole is 2 grams of hydrogen, okay? 1 mole of hydrogen is 2 grams. So now my moles of hydrogen cancel, and I'm left with just grams of hydrogen, which is what I'm looking for. So then I just go across. So remember, you can divide or multiply, it doesn't matter, okay? So 34.8 times 3 divided by 2 times 2 divided by 1 will get you 104.4 grams of hydrogen. And you can do the multiplication and division in any order you like. You will still get the same number, okay? All right, so let's look at number 9. What was the given in the example above? Well, right here. This was our given, right? And then we did our mole ratio and our molar mass, okay? So our given was 34.8 moles of ammonia, okay? Where did the 3 moles of hydrogen to 2 moles of ammonia come from? That came from our balanced equation. Remember, when we're going from moles to moles, that has to come from the balanced equation. It can come from nowhere else. Where did the 2 grams of hydrogen to 1 mole of hydrogen come from? That came from the molar mass, which was calculated from the periodic table. Okay? Okay. All right, so I'm going to do one more with you. I'm going to look at number 12 with you. So look at the periodic table. How much does 1 mole of hydrogen atom weigh? Well, if you look at your periodic table at the front of your notebook, okay, 1 mole of hydrogen equals 1.01 grams of hydrogen. And that's just the atomic mass there at the bottom of hydrogen. Why is the molar mass of hydrogen 2.0 moles in the example above? Well, notice if 1 mole, sorry, I should not put the 2 there, should I? 1 mole of hydrogen. Notice there's no subscript there. It's 2, and that is because hydrogen is a diatomic, okay? Okay, so it's definitely a diatomic. Remember, we have our 7 diatomic that makes our number 7. Always remember, if it's a diatomic, it will have 2 at it in any balanced equation if it's on its own, okay? All right, so I'm going to leave you guys here. I'm going to let you go and double check. You're going to do 13 here, okay? You're 13, you're going to double check the 104, which means you're just going to check the math, okay? And then what units is molar mass used to convert between, and why did you have to start with the mole ratio when the question was asking for grams? Okay, actually, you know what? I'm going to go through these guys a little bit with you. So you're going to check your math. So if you do 34.8 divided by 2 times 3, it will equal 104.4. Everything is good. What units is the molar mass used to convert between? Moles to grams or grams to moles. It goes back and forth. It's moles to grams or grams to moles. Why did you have to start with a mole ratio when the question was asking for grams? Why did I have to start with a mole ratio when it's asking for grams? Because a balanced equation, okay, is only in moles. There is no grams in a balanced equation. It's only moles. So look at, I've even done a couple extra for you guys. Aren't you guys so excited? Okay. And so I'm going to go ahead. I'm going to look at number 16 for you guys. I'm going to look at 16A. I'm just going to do that one with you guys. Why not, right? So it says, given the following chemical equation, and we have 4 phosphorus plus 5 oxygen leads to 2 phosphorus oxide. I'm going to check these. I have 4, 10 oxygens, 10 oxygens. So what is the molar mass of P2O5? So actually, P2O5, you know what I'm going to have to do is I am going to have a periodic table. Okay, so let me bring that up just a minute. So what I want you guys to do while I'm actually doing this, what I want you guys to do is go ahead, pause this video, calculate that molar mass of phosphorus oxide there, and see if you match up. So go ahead and pause the video now. All right, so let's take it back. So let's calculate our molar mass. So if I look on the periodic table that's in the front of your notebooks, as you can see, I have 2 phosphorus. And if I read off, phosphorus is number 15, okay? I'm going to round it. So phosphorus equals 31 grams, and oxygen off the periodic table equals, I'm going to round it, 16. Okay, so I have 2 phosphorus and 5 oxygen, so the molar mass of P2O5 is going to equal 2 times 31 plus 5 times 16. Okay, so I'm going to have, let's go ahead and calculate that out. Should be, sorry, I'm just going to double check this one really quick. Should be 142 grams of P2O5 per 1 mole. P2O5. That is the molar mass, okay? So I'm going to do B for you guys too here. So how many grams of phosphorus oxide are formed from 3.4 moles of oxygen? So notice I'm looking for grams of phosphorus oxide to 3.4 moles of oxygen. I see grams in my question. I know I need the molar mass of phosphorus oxide. Whew, good thing we did it in A. So then I can go ahead and start. So I can start with my given. That's my first thing. So I'm going to write that 3.4 moles of oxygen. Then I'm going to multiply. Remember, my next thing is my mole ratio. Okay, and I have moles of oxygen, so I'll put those on the bottom. The units I have go on the bottom, and the units I want. Now, remember, I'm going to have to use the mole ratio, which is from the balanced equation. I cannot go from moles to grams in the mole ratio. Mole ratios only go moles to moles. So I'm going to need to go to moles of P2O5. And then I'm going to go ahead and go up to my equation to get my mole ratio. So I have 5 moles of oxygen right here to 2 moles of P2O5. My moles of oxygen are going to cancel. So now I'm going to do my next conversion, which is, remember, we're going to do ratio, and then we'll do molar mass. Okay. So I'm going to have moles of P2O5, and molar mass is in moles and grams, so grams is on top. Oops. So I'm going to look up here, 1 mole P2O5 is 142 grams. Then I can go ahead and cancel moles of P2O5, and I can go ahead and calculate it out. So if I take 3.4, let's say I times it by 2, divide by 5, and then I'm going to times by 142, divide by 1, and I should get 193.12 grams of P2O5. So what does that mean? That means if I have 3.4 moles of oxygen to start with, I can create 193.12 grams of phosphorus oxide. No more. That's as the most that I can create, okay? Please notice you're going to go mole ratio and molar mass, okay? And down here as you get past 17, it's going to flip. So then you're going to start, instead of with moles, you're going to start with grams. And you'll see how that works. Okay, guys, you're on your own. You're going through number 26. If you need any help, please find me on Zoom, email me, or set up a private Zoom session with me. Okay, hope you guys are safe and healthy. Bye.